Not surprisingly, the 12-factor app has 12 tenets. Let's cover the first 6. First, we have the code base. This is a unified collection of code, one per app, which might have multiple deploys. Deploys are running instances of an app. This central location provides all the capabilities of version control. Through release versioning, different iterations of the app can be built off the common codebase. Next, we should explicitly declare our dependencies. Never rely on specific packages or binaries being available on a system. Even common tools like curl and wget aren't available by default in many Linux distributions. For language-specific packages, this is even less likely. A developer must separate code from configuration. Specifying usernames, passwords, file paths, and other data consumed by an application should be moved out of the source code. Encodings like JSON, YAML, and XML are excellent for storing config data. In multi-tiered applications, a backing service might be a database from the perspective of a controller or middleware component. These services should appear like they're attached regardless of whether there is a network in between. This improves the code's modularity. The build, release, and run stages should be strictly separated. Building includes compiling code into executables. Releasing means applying the specific config to a given build, and running means deploying into production. CI/CD pipelines combined with version control release tagging help separate these phases into discrete steps. The processes tenet means that an app should be comprised of stateless, share-nothing processes. This improves scalability and modularity by having specific processes do specific things. A process should never rely on data being cached in memory or on disk for future requests. Here are the last 6 tenets of the 12-factor app. Port binding probably sounds familiar, as this is precisely how Docker maps the private container ports to the externally accessible published ports. This allows the app to be portable, and when the app is deployed, the port bindings can change. You don't have to use TCP port 443 for HTTPS as an example. To achieve concurrency, 12-factor apps should scale out using processes and threads. Perhaps there is one process to handle HTTP requests and a worker process to start worker threads for handling the API request after receiving them from the web front end. This improves performance, efficiency, and scalability. 12-factor apps can be quickly spun up and shut down. This is part of what makes containers so popular. They are stateless and disposable since they often hold no persistent data. This simple on-off switch enables fast configuration changes and component swapping, improving modularity and flexibility. If nothing else, maintaining parity between environments is a huge advantage of CI/CD. Development and production environments are always going to be different, but those differences are minimized with smaller, more frequent deploys. This constantly updates prod with new features from dev. Troubleshooting applications is hard, especially ones with poor observability. It's even harder with poor logging. The app shouldn't concern itself with managing log files, but should instead print to standard output. The logs should be aggregated and time-ordered, providing a clear chronology of all events. When we run administrative tasks, like opening a console or updating a database, we should run them in the same environment as the main app. That means they should be in the same codebase, use the same config files, and ship with the app as a utility package. This improves maintainability. Before viewing the next clip, ask yourself this question: how do you think our CRM app stacks up against these 12 tenets?